evening. That's not part of the act. Right, okay, hi, I'm Harry. I'm a bottom physicist. That came out wrong. What I meant to say is I'm a high-energy physicist or particle physicist, but my speciality is bottoms. I'm fascinated by bottoms. They're wondrous, they're sexy, and they can help us to understand the origins of the universe. I should probably explain that bottoms are a type of particle. They're tiny, tiny things. They weigh about half a nanogram, which is about 20 trillion times lighter than your average human bottom, which are also great, but not the main focus of my research. I just finished a PhD, and I spent 3 years working on a machine that was built specifically to study bottoms. It's based out in Geneva, about 200 metres under the airport duty-free shop, where they sell Toblerones and fondue sets and little models of milkmaids. Great country, Switzerland. And it's actually based on the Large Hadron Collider. You may have heard of it. It's the biggest machine ever constructed, a 27-kilometre around particle accelerator. It's sort of the Eric Pickles of the collider world. And it's really a place of extremes. It simultaneously contains the hottest place on Earth and the coldest place in the universe. And if you want to get a sense of what that's like, the closest you can come is to stand in a bucket of ice while biting into a freshly cooked West Cornwall pasty. What the LHC does is it takes protons, the little bits from inside hydrogen atoms, and whizzes them round and round in a circle till they're going just slower than the speed of light, and then it smashes them into each other. And through E equals mc squared, their energy is converted into stuff in the form of bottoms. And we're actually the most abundant source of bottoms in the world, which we're very proud of. And we built a special bottom detector to study them, and it's called LHCb, which, if you speak acronym, you'll realise stands for Large Hadron Collider Bottom. Except at LHCb, we tend to refer to the B particle as the beauty particle, which was actually the name coined when it was first discovered, but physicists showing their usual flair for naming things plumped for bottom over beauty, which is a dilemma many of us face every day. But I didn't want to get up on stage tonight and introduce myself as a beauty physicist because I didn't want you to think that I was a twat. So why are we so fixated with bottoms? Well, particle physicists have got a problem, aside from the obvious. We spent the last 50 years developing what is probably the most successful theory ever written. It describes all the stuff you and I are made of and all the forces that hold us together with dazzling precision. It's kind of the closest we have to a theory of everything, and they gave it a really suitably impressive title. They called it the Standard Model. Gets the heart racing. Not even the deluxe model, just the Standard Model. And to give you an idea of how good the Standard Model is, it can predict, for example, the magnetic field of the electron to a precision of better than 1 part in a billion. That's really very good. I mean, Mystic Meg, she only got her predictions right 1 in 50 times, and she was on the telly every Saturday. So, fantastic theory. It has a couple of niggles, one of which is that it predicts the universe doesn't exist. This is what theorists call a feature of the universe. Experimentalists might be less polite. So why don't we all exist? Well, it's basically down to the type of stuff in the universe. There are 2 types of stuff. There's matter and there's antimatter. And you can think of antimatter as sort of matter's weird twin. And in the Standard Model, matter and antimatter are perfect reflections of each other. Now, as we all know from watching Brian Cox on the telly, the universe began with a Big Bang, where energy was converted into matter and antimatter. And because of this symmetry, they should have been made in equal quantities. Now, as we also know from reading Dan Brown, when matter and antimatter meet, they annihilate, wipe each other out, leaving nothing but pure energy. So, if we combine the theories of Cox and Brown, we come to a startling conclusion, which is what should have happened at the Big Bang is matter and antimatter get made in equal quantities, and sometime later they meet up and annihilate each other, leaving a cold, dark and lifeless universe, a bit like Middlesbrough. But we don't all live in Middlesbrough, so what's going on? Well, it must be something to do with this symmetry between matter and antimatter. It can't be a perfect reflection. It must be more like one of those weird fairground mirrors that make you look like a senior member of the Conservative Party. You know, they give you a forehead that only generations of selective breeding can achieve. And this is where the bottoms come out. Bottoms are actually a member of a family of particles called quarks. And quarks are a bit like my friend Dave. Now, Dave's a lovely guy, but you will never find him outside of a relationship. As soon as he's shot of one girl, he's straight on to the next. And quarks are the same. They're always coupled up. Or sometimes they have a three-way, which I'm told is more fun. And I study a particular coupling of the bottom quark with the strange quark to make a strange bottom. And the strange bottom has a peculiar property. It can flip backwards and forwards between matter and antimatter. So it sort of goes strange bottom, anti-strange bottom, strange bottom, anti-strange bottom, and so on. And what we do at LHCb is we study how long it spends in the bottom versus anti-bottom state. And if we see a difference, that tells us something about this weird warped reflection. So the LHC's been running for 2 years. We've spent 4 billion euros. Thousands of people have been working very hard. So what have we found? Well, so far, all the evidence suggests that the universe shouldn't exist. But don't panic. If you're feeling existentially challenged, more data's coming next year, so we may yet get a result that will save us from oblivion. Now, as a particle physicist, I couldn't really get up on stage and not discuss what probably is the most exciting scientific discovery of this afternoon. I'm sure, like me, you were glued to your computer screens at around 1 o'clock this afternoon, watching the live webcast of the Higgs boson announcement, live from CERN. And if any of you actually did watch it, one of the most remarkable things about it was the spokesperson for one of the experiments, the Atlas experiment, presented her results using Comic Sans as her main font. Which I thought it was a bit like turning up to your murder trial in a silly hat. The way we find the Higgs boson at the LHC is, again, we bang things into each other, and what you get is, if you can imagine a sort of graph with energy along one axis and the number of particles on the other, you get a sort of smooth background noise, that it's sort of shunting that into the set there, and then if the Higgs exists, you get a great big throbbing peak on top of this flat noise. And the throbbing peak, that's a technical term in particle physics. And what they showed today was really more of a semi. So we're not quite sure if it's happening yet. The game's not quite on, but so if we give it a bit more time, pay a bit more attention, hopefully we can turn it into something a bit more impressive, and next year we'll be able to say with a bit more certainty whether this all-important Higgs boson exists, the thing that's supposed to give us all mass. As I said, I've just finished a PhD. And so I was really disappointed with the paper that came out of my final thesis, mainly because it had a really dull title. It was called A Measurement of the Effective BS to KK Lifetime at the LHCb Experiment. Not exactly going to set the world on fire, which is actually another project of mine. So my main aim now is, for my next piece of research, to come up with something with a catchier title. Now, I told you before that quarks are always coupled up. Well, there's real interest in studying something called a bare quark, a sort of quark on its own, a quark without a girlfriend, if you like. So I've come up with what I think is the perfect title for a paper, which is A Search for Bare Bottoms at the Large Hadron Collider. That would really make me very happy. Thank you very much. It's been a lovely morning.